Dear students, I am Ramesh, chemistry faculty from Vidyamandir Metric Higher Secondary School, Uttangarai. Let us discuss about lattice energy. And what do you mean by lattice energy? So, the lattice energy is nothing but the amount of energy required to completely remove the constituent ions from its lattice. So, it is the amount of energy required to remove its constituent ions from its lattice. So, from its crystal lattice is nothing but lattice energy. Now, we may take that here, that is NaCl is a crystal lattice. NaCl solid is present in a crystal. Then, the amount of energy is required, that is the lattice energy. The amount of energy is required to split the NaCl molecule in the crystal to its constituent ions. That is, it will be formed Na plus and that Cl minus at infinite distance. So, there is no interaction between Na plus and Cl minus. So, we may remove the constituent ion from a crystal lattice at infinite distance, which is known as lattice energy. And getting that this delta H is given, that is 788 kilojoule per mole. 788 kilojoule per mole. So, what do you mean by 788 kilojoule per mole? If you have taken 1 mole of NaCl, 1 mole of sodium chloride, the amount of energy is required to split its constituent ion is nothing but 788 kilojoules. That is, 788 kilojoules of energy is required to split the NaCl molecule into its constituent ions. Now, how will you calculate this lattice energy? Lattice energy is calculated by Born-Haber cycle. Born-Haber cycle. So, Born-Haber cycle is introduces to find the lattice energy and which is not directly measured. So, lattice energy cannot be calculated directly. So, by this Born-Haber cycle, we may calculate the lattice energy. And here, the lattice energy or Born-Haber cycle applying Hess's law. Hess's law of summation. Hess's law of summation. So, it applies Hess's law of summation and here it consider only the ionic molecule. So, it consider the ionic molecules. And here a metal may be reacted with halogen or maybe that is oxygen and form that metal oxide or maybe metal oxide. So, metal halide and metal oxide formation, we are taking this Born-Haber cycle. Now, we may take the simple Born-Haber cycle of metal halides. So, we are take Born-Haber cycle. We are taking that the metal and it is in a solid state. Metal is present in a solid state and it is reacted with the halogen X and form that the metal halide and it is in a solid. Now, we are taking that here actually any halogen is a diatomic molecule so that it is X2. So, by balancing this, we are taking this of X2. Now, the first process, we are taking the metal solid on sublimation that will be produces that is metal gases. So here there is a sublimation process, the solid is converted into gases. So here the enthalpy required is taken as delta H1. Enthalpy change for sublimation is known as delta H1. Now the metal is converted into, that is M plus. Then metal is converted into ion. Then it is in a gaseous state. So metal is converted into ion by loss of electron and the process is known as ionization. So we are take delta H2 and it is known as ionization. So ionization, that is enthalpy of ionization. Enthalpy of ionization. So delta H1 refers enthalpy of sublimation. Enthalpy of sublimation. Now we are taking that is X2. It is also that is a gas. That is all halogens are gases. Now the X2 is converted into X. So X2 is converted into X, that is a halogen gas. Now it is dissociation. That is X2 become that X. So that here delta H3 is explains change in enthalpy of dissociation. It is known as dissociation. Now X is converted into X minus. X is converted into X minus and it is in that gaseous state. Now how will you get X to X minus? By adding of electron. Addition of electron is known as electron affinity. So here it is delta H4 refers electron affinity. Electron affinity. And here we are taking M become M plus and X become X minus. X become X minus. So what will happen? It is a cation and anion. So cation attracted the anion and formed that the solid Mx, that is metal halide, and here it is known as U, that it is lattice energy. Lattice energy. Now we are taking the direct one M plus of X and it is delta H formation of Mx solid. Delta H formation of Mx solid. So it is the Barnabas cycle. By applying H's law, we are taking this delta HF. So applying H's law. H's law of summation. What is it? Delta HF. Delta H formation of a metal halide solid is equal to, that is delta H1 and plus delta H2 and delta H3 and delta H4 plus U. Then from that we may find the lattice energy value. So what is that lattice energy? U is the lattice energy. So here U, which is equal to delta HF minus, that is delta H1 and delta H2 and delta H3 and delta H4 value. So we may get the lattice energy value by Barnhaber cycle. Now consider the problem according to Barnhaber cycle. And they are given delta H formation value of sodium chloride. So it is for sodium chloride, that is Na plus Cl2 become that NaCl. Then we want to find out the lattice energy of a sodium chloride. They are given delta HF and sublimation and ionization and dissociation and electron affinity value. Now find out, that is delta U, we are taking that Na, sodium solid, and chlorine gas is converted into NaCl, sodium chloride, that is a solid. Now by balancing we are take, that is of H2, then it is delta H formation of sodium chloride. Now the first one delta H1. So sodium solid is converted into sodium gas. Then it is nothing but delta H1. Then the values are given. What is it? It is 108.7 kilojoules per mole. Now it is a sublimation value. And the sodium gas is converted into, that is sodium ion. Sodium ion. Then it is ionization, that is delta H2. Then it is ionization. Ionization value is given. What is that? It is 495 kilojoule per mole. 495 kilojoule per mole. And the next one, the dissociation, that is chlorine molecule, that is Cl atom in a gaseous state. And the dissociation, it is nothing but delta H3. The dissociation value, it is 244 kilojoules. Now this chlorine gas is converted into Cl minus gas. Then it is nothing but, that is delta H4. Then it is known as electron affinity. And the electron affinity value is minus 349. So it is minus 349. Now these two are combined and form that NaCl, and it is U. So applying SS law. What is that SS law? Of summation, we are taking delta HF, which is equal to here delta H1 plus delta H2 plus delta H3 plus delta H4 and plus U. Find out the U. U is nothing but, that is delta HF minus here delta H1 and delta H2 and delta H3 and delta H4. Now substitute the values. Delta HF. Delta HF value is minus 411. So it is minus 411.3. So here minus 411.3 minus into delta H1 is 108.7 and delta H2 plus it is 495 and plus delta H3. And listen, in the case of delta H3, half delta H3 is used because half molecule is taken and it is for 1 moles. So half mole is taken, so 244, half mole it is 122. 122 and that is delta H4. Delta H4 minus, that is 349. Then it is nothing but U. So by it is 411.3 minus, by summing up, then we are getting, that is 376.7. Then the U value is minus 788 kilojoule per mole. So here the lattice energy is minus 788 kilojoule per mole. It refers negative sign. And the negative sign refers when Na plus is combined with Cl minus and form that NaCl. And here the formation of NaCl from its ion is a exothermic. So this is the exothermic value. Then if you are consider the lattice energy, the reverse process, so it is plus 788 kilojoule per mole, then it is the lattice energy. Okay. Now need for second law of thermodynamics, and you know that thermodynamics first law of thermodynamics. And here according to first law of thermodynamics, it is nothing but the conservation of energy. What is the conservation of energy? Energy can neither be created nor be destroyed. But one form of energy is converted into another form of energy in an equal amount. It is nothing but conservation of energy. It is first law of thermodynamics. According to first law of thermodynamics, it introduces delta H. What is it? Delta H? Enthalpy, change in enthalpy. And the change in enthalpy is negative. Then it considered as a spontaneous process. It is a spontaneous process. So according to first law, negative enthalpy value tends to spontaneous. So it consider all spontaneous process or all exothermic process are spontaneous. It does not, it occurs its own. So all exothermic, what is the delta H negative? Then it is nothing but exothermic reaction. So all exothermic reactions are considered as spontaneous. Then it occurs its own. It is not to be induced. Now we may consider the first example. We are taking a hot water in a glass. So we are taking that the hot water. So it is a hot water. Hot water is taken as a glass. So it is a hot water. Now it is a system. We may consider it is a system. Now after some time what will happen? If you are taking a hot water, after some time what will happen? The hot water become cold by loss of its energy. So the hot water become that cold. The hot water become cold. So it will become that cold. The hot water become that cold by loss of energy. So it produces energy. Now this process is a spontaneous process. We are not induced. The hot water become cold. But it will be occurs its own. Automatically after some time the hot water become the cold. Hot water become cold by loss of energy to that surrounding. Now it is a spontaneous process. Spontaneous process. Now consider the reverse. If you are taking a cold water, then it is spontaneously become hot. It never be happen, correct? So if you are taking a cold water, it cannot spontaneously become hot. So that some process are spontaneous, it will be occur its own. But the reverse process is non-spontaneous. It is a non-spontaneous. So it is a non-spontaneous. It cannot be occur its own. Cold never be hot. But if we are induced, suppose in a cold water we supply energy, then it will become hot. But it is a induced one. We are externally giving that energy to that cold water and become that hot water. So we are taking hydrochloric acid is reacted with sodium hydroxide. Hydrochloric acid is reacted with sodium hydroxide. Then it will be formed that sodium chloride and that water. Then this reaction is exothermic. So here delta H value is negative, and you know that the negative value is 788 kilojoules per mole. 788 kilojoules per mole. So it is the exothermic reaction. Then it will be occur its own. It is not to be induced. When hydrochloric acid is added with the sodium hydroxide, it will be formed sodium chloride solid. And it is a spontaneous one. It is a spontaneous. Now, if you are supplying energy to sodium chloride, what amount of energy? If you are supplying energy, 788 kilojoules of energy is supplied to sodium chloride, then what will happen? Here sodium hydroxide and hydrochloric acid will be formed. But the reverse process is never be formed by supplying energy. So some process are occur only in particular direction. So the spontaneous reactions are occur. Spontaneous reaction occurs only in particular direction. Only in particular direction. Particular direction. So not all those form of energy is converted into all those form of another one energy. So it is the drawbacks of first law of thermodynamics. So to complete it, we introduces second law of thermodynamics. Second law of thermodynamics. So second law of thermodynamics will introduce us the state function. So it introduces the state function, that is delta S. What is that delta S? Delta S is nothing but change in entropy. Change in entropy. So we may introduce this entropy concept. So second law introduces the entropy concept, but first law introduces enthalpy, that is delta H concept. Now here we may take that entropy. What is that entropy? Entropy is a measure of randomness or disorderedness. So entropy is the measure of randomness or disorderness. So we predict the spontaneous process, we get the next variable, that is entropy. By this entropy we may predict the spontaneous process. So we are taking that entropy mathematically. Here S is equal to Q by T. S, which is equal to Q by T. So entropy is defined as amount of heat involved in a system at a constant temperature, is nothing but entropy. And it is the measure of randomness or disorderedness. Now we are taking the statements of second law of thermodynamics. And here the first statement is entropy statement. Entropy statement. According to entropy statement, increase in entropy tends to be spontaneous. So what is that? Increase in entropy tends to be spontaneous. So for a spontaneous process, the entropy should be increases. So if increase in entropy tends to be spontaneous, then it is nothing but entropy statement. Now if you are consider the irreversible process, so we are take the irreversible process, and you know that all natural processes are irreversible. And all natural processes are irreversible, and the irreversible processes are considered as the spontaneous. It is considered as the spontaneous process. And here for irreversible process are considered as a spontaneous. For a spontaneous process, what is that? Entropy should be increases. So delta S total is greater than 0. So delta S total is greater than 0, or delta S universe is greater than 0, is nothing but spontaneous process. So what is the condition for spontaneity? Delta S universe or delta S total is greater than 0. And if you are taking this delta S total is nothing but delta S universe is nothing but, if you are taking delta S universe is nothing but, if you are considering delta S system and plus delta S. So delta S universe is nothing but delta S system and delta S surrounding. So if you are taking here delta S system plus delta S surrounding is greater than 0, then it is for spontaneous process. Now we are taking, that is for a reversible process. For a reversible process, what will happen? And the reversible process attain that equilibrium, so that here delta S universe become that 0 for reversible process. Now, if delta S universe is 0, if we are taking delta S universe is 0, then what is that? Here, delta S system which is equal to minus delta S surrounding. Minus delta S surrounding. So, delta S system is nothing but minus delta S surrounding. Then only we may get delta S universe becomes 0 for that reversible process. So, we may take the spontaneity condition. If delta S universe is greater than 0, then the process is spontaneous. It will be occur its own. And it is not to be induced. Then it is a spontaneous process according to entropy. And if it is a reversible process, then the delta S universe is 0. For non-spontaneous process, delta S universe is less than 0. That is, decrease in entropy tends to non-spontaneous. Now, so we are taking the second statement. It is Kelvin-Planck statement. Kelvin-Planck statement. According to Kelvin-Planck, it is impossible to construct a machine which absorbs heat from a single sources or hot body will completely converted into work and without transforming heat to the sink. So what is that? It is simply Kelvin-Planck statement, 100% efficiency is not possible. So, even if the ideal machine, frictionless machine, 100% work done is not possible, is nothing but Kelvin-Planck statement. So, the statement is, it is impossible to construct a machine. It is impossible to construct the machine. Impossible to construct the machine which absorbs heat from hot body, which absorb heat from single hot source and completely converted into work, completely convert into work without transfer heat to the cold sink. Then it is known as Kelvin-Planck statement. And it is nothing but, if you are taken the ideal frictionless machine, you are taking the ideal frictionless machine, 100% efficiency is not possible. 100% work done, 100% work done is not possible. Not possible. Then it is nothing but Kelvin-Planck statement. Now, we may take that the efficiency of a machine is identified by Carnot cycle. So, by a Carnot cycle, we get the efficiency of a machine. Now, we are take the efficiency. So, efficiency of a machine is nothing but neta. Neta, which is equal to here modulus of QH minus modulus of QC divided by modulus of QH. This is nothing but efficiency of a machine by Carnot cycle. And what is that QH? Here QH is nothing but amount of heat absorbed from hot reservoir. So heat absorption, amount of heat absorbed from hot reservoir. And QC QC is nothing but heat given to cold reservoir. Then it is nothing but efficiency. Now, if you are taking the percentage of efficiency, it is multiplied with 100. Now, we are taking that the efficiency of a machine, that is neta, which is equal to modulus of QH by modulus of QC divided by modulus of QH. Then, you know that here we are taking that it is 1 minus, that is QC by QH. 1 minus QC by QH. We are taking it is 1. Now, for a reversible process, we are taking reversible process. If you are taking a reversible process, what is that the condition? Delta S universe is equal to 0. Then, what will happen? Here, delta S system is equal to minus delta S surrounding. Delta S surrounding. Now, if you are taking delta S, what is the delta S? Delta S is nothing but Q by T. So that here Q H by TH is nothing but minus, that is QC by TC. Now, we may alternate this one. So, what is it? Here TC by TH is nothing but minus QC by QH. Then, if you are taking the modulus, so what is it? Here TC by TH is nothing but modulus of QC by modulus of QH. Then, you know that it is the second. We may substitute this into first one. So, what is it? Here we are getting that the percentage of efficiency or efficiency is nothing but 1 minus here TC by TH at a different temperature. So, if you are taking the percentage of efficiency, which is nothing but 1 minus TC by TH into 100. So, it is percentage efficiency. And the next statement, a Clausius statement is nothing but it is impossible to transfer energy from cold body to cold body or cold reservoir to hot body or hot reservoir without doing some work. Without doing some work. So here it is a Clausius statement. So these are the statement of second law of thermodynamics. Now we are taking that the unit of entropy. Unit of entropy. What is that unit of entropy? Entropy is nothing but delta S, which is nothing but Q by T. What is the Q? Amount of heat. Heat, the unit SI unit is joule or kilojoule, and temperature in Kelvin. So that here it is joule by Kelvin, or here joule Kelvin inverse or kilojoule Kelvin inverse. Spontaneous or randomness. What is that spontaneous or randomness? Now we are considered that is melting of ice and evaporation of water. We are taking here that is 3 flasks, 3 conical flasks, and here we are taking that ice. We are taking ice here. Here there is a ice cubes. And here there is a ice cubes. Then it is converted, it is a shield one. Then it is converted into melt. Then it will become that water. So here that is a water liquid. So we are taking here, it is melted, then it is a liquid water, then it is a solid ice. Then we are taking, it is also closed, then it is a shield. So it is a shield one. And here also we make it same. Then now it is converted into, now it is on heating, then it will be converted into water vapor. So here we are get the water vapor. So here it is the shield, then so that is H2O in a gaseous state. Now what will happen? Listen, if we are taking that ice and it is in a solid state, so all those water molecule is orderly arranged, and the molecule, a molecular movement is very little. Molecular movement is very little because it is in the ordered state. If you are converted into water, the ice solid is converted into water, then what will happen? Here the molecular movement is somewhat greater than that of ice, so that there is a randomness or disorderness. So the ordered state become that disorder. So it is nothing but the disorderness. Increase in entropy tends to be spontaneous. So melting of ice is spontaneous. So it is spontaneously converted into water. Then here delta S is greater than 0. Now we are taking that the water molecule liquid, that is evaporation of seawater. And it is a spontaneous process, the natural process, you know that. Then here the water molecule is converted into gas. So the water molecule is converted into gas, then what will happen? The randomness is increases. The molecular movement will be very greater than that of the liquid water and that ice, so that the randomness delta S is greater than 0. So here if delta S, that is ordered state to disordered state, then the process all are spontaneous. So what is the spontaneity condition? Delta S is greater than 0. So according to first law and second law, for the spontaneous process we are taking, it is a spontaneous process. If you are taking a spontaneous process, that is delta H should be negative and delta S should be positive. Thank you.